Okay, so now we are moving to the second part of day one on thermochemistry, and it is related to calorimeter. So, what is happening with calorimeter is that it's measuring the calories of that. It's a tool. It's a way to measure the calories of that uh, a substance, even a substance as you probably have seen this, those labels on the hood that are saying 350 kilojoules or kilocalories. And the way that it is measured, it is a combustion reaction is happening into a bomb calorimeter, and then the temperature is increased, the temperature of the surroundings is increased, and since it is a bomb calorimeter, that we are dealing with an isolated system, which means that the potential energy that is released as a result of breaking the bonds of the substance is released into the surrounding, which in a lot of cases is equal to is water, because it has a lot of very high specific heat capacity. And then the change of temperature of water is measured, and then the calories are counted, are calculated. The assumptions that is done when we are dealing with calorimeter is that it is an isolated system, which, as we said, the mass and energy are not mass is changing, but energy is transferred. The reaction takes place in a solution, and the temperature change of water, which is part of the laws of thermodynamics, the temperature change of the waters is an indication of the amount of energy that is transformed from the reaction from the chemical system to the surrounding. And since it is an isolated system, the heat lost is equal to heat gain. Okay, so the calorimeter that we use often in chemistry in high school is two styrofoam cups when we have a stirrer, and then the thermometer in the lid. There are two holes, one that is for the stirrer and one that is for the thermometer, in which we measure the initial temperature of water and the final temperature of water after the reaction is happening, because in the double styrofoam cup, in one of them, in the inside one, we put the reactants, and therefore the products are formed. So during that chemical change, the reactants and the product forming the products, the water changes the temperature, and this change of temperature of water is an indication of the amount of energy that is absorbed from the breaking the bonds on the chemical system. We even mentioned that water is very good. It serves us as a very good surrounding because of the specific heat capacity, the relatively high value of the specific capacity that it has. Now, what specific heat capacity is the amount of energy, or the quantity of heat, the amount of energy required to change the temperature of 1 gram by 1 degree Celsius. So specific heat capacity is known with a letter C, is unique for every material. It doesn't matter what material is it or substance. And the units for it are joules, because it's the energy required to increase 1 gram of the of this substance or of this surrounding by 1 degree Celsius. Now, uh, energy is measured in joules, and you know this even from science 10, or in kilojoules. Let's take a look at those units and then let's see if the energy is expressed in kilojoules, then uh, it, joules, grams, joules per grams and degree Celsius is the same as joules per kilograms and degree Celsius. Why is that so? Because kilos, either that being joules or grams, kilojoules or kilograms, is the same as saying joules times 10 to the power of 3, or kilograms for kilograms is grams times 10 to the power of 3 degrees Celsius. So this times 10 to the power of 3 is canceled out, and then it's the same thing as we had prior here, joules per gram degree Celsius. On your data booklet, you will see the specific heat capacity for the elements that are used the most in chemistry, or that you are presented mostly on the physics 30, and the formula, which you have seen it even before, is Q, which is the heat or the energy, is equal to mc delta T. In this formula, Q is the heat that, or the energy that is absorbed or it is released from the surrounding. M is mass, and it is measured in joules or kilojoules. And mass, M is the mass of the surrounding, and it is measured in grams or kilograms. Usually we go, if it is in joules, then in grams. If it is in kilojoules, then it is in kilograms. C is specific heat capacity, and again, the number and the units that you have in your data booklet are joules, grams, degree Celsius, which we prove that are the same as saying kilojoules per kilogram degree Celsius. And so this is specific heat capacity, and delta T is the change on temperature. So it's T final minus T initial. And in every question that you will see will be on a degree Celsius. Usually we say that when it is in degree Celsius is with a lowercase t. And now it works perfect, because when we work out with units here, mass being in kilograms, specific heat capacity in joules or kilojoules per gram or kilogram degree Celsius, and the temperature in degree Celsius, then the units in the right part of the equation are, most of it are canceled. What is left is either joules or kilojoules. So let's see now some examples on the calorimeter. Let's calculate the quantity of heat that flows into 1.50 liters of water at a temperature of 18 degrees that is heated in an electric kettle of 98.7 degrees Celsius. So what is given here is the mass of water is equal, actually is the volume of water, but since the water has 1-to-1 ratio of volume and mass, so 1 milligram of water is equal to 1 milliliters, which means that 1 liter of water is equal to 1 kilogram of water, and in our case, So these are 1 to 1, 1.50 kilograms of water. And we have the initial temperature of 18 degrees Celsius and the final temperature of 98.7 degrees Celsius, and we are looking for Q. So based on the formula, what do we have? Q is equal to mc delta T, or Q is equal to 1.50 kilograms, and C is found in your data booklet, and you will look for C of water, which is 4.19. In your, as I said, in your data booklet is joules per gram degree Celsius, but we prove that it's the same. So since the mass of water is in kilograms, then I will say that it is in kilojoules per kilograms degree Celsius times the temperature change is 98.7 degrees Celsius minus 18 degrees Celsius. So now let's work with the units. Kilograms and kilograms is cancelled out. Degrees Celsius and degrees Celsius is cancelled out. And what is left is in kilojoules. So when we enter in our calculator 1.50 times 4.19 times the difference, 98.7 minus 18, then we will have 507 kilojoules, which is the final answer to the correct significant digits, because significant digits on this question is 3, and since we are multiplying, then we will go with the lowest number of significant digits, and that number is 3, so the final answer will be 507 kilojoules. Okay, now let's take a look at the other one. Determine the specific heat capacity of a rock if the heat, so in this case, heat is 0.72 megajoules and is released by a rock with mass of 2.50. So 2.5, sorry, not 2.50, 2.5 kilograms. When it's cooled down from 300, so T initial is 350 degrees Celsius into T final of 15 degrees Celsius. As you see, and we are looking for C here. As you see here, what the lowest number of significant digits is 2, so the final answer should be 2, and the answer is here and in brackets. And considering the fact that the leading zeros are not considered as the significant in your answer, then the 0.86 is to the correct number of CDs. So now we'll start with the formula. Q is equal mc delta T. What we are doing is we are looking for C, which we can isolate it as Q is equal to m times delta T. Now, the heat or the energy is given in megajoules, and mega means times 10 to the power of 6. So this will be the same as saying 0.72 times 10 to the power of 6 joules over mass is given in kilograms. Let's convert it into grams since we are dealing with joules here. So will be 2.5 times 10 to the power of 3 grams times the change on temperature is final minus initial. So will be 15 minus 350 degrees Celsius. And what do we have here as the correct answer? You enter it in your calculator as the correct answer to the correct number of sig digs is 0.86 joules per gram degree Celsius. So now when you see this, you will notice that the change on temperature is equal to a negative number. And then you may wonder, do you have to say negative or positive? Actually, when we are dealing with specific heat capacity, we do not specify if it is a negative or positive, because specific heat capacity is just an indication of what is either the energy is absorbed or released, doesn't really matter. It is an energy that is into the object based so that you increase or decrease, change the temperature, in other words, change the temperature of 1 gram of material by 1 degree. So it doesn't really matter. But as you see here on the question, the heat is released by the rock. So the rock is the system and the air is the surrounding. Is released by the rock. So if we are being very, very specific, this heat is negative, and then the negative of the temperature, the difference of temperature will cancel out with the negative that heat has. However, we know that the specific heat capacity can be expressed only in a positive value, and we will talk about the enthalpy change and if it is positive or negative when we will see that topic in the second day of thermochemistry. For now, I would like you to go and practice on the workbook questions 3 to 5 and 1 to 13. I will talk to you. You will refer to the workbook that is posted on DeepWell under the content at the thermochemistry tablet. Okay, so I will close this part of this broadcast, and then we will see and talk more about those kind of questions in class.